Hello class, welcome to lesson 5.5, which is all about inequalities involving absolute value. By the end of this lesson, you should be able to solve and graph absolute inequalities using the less than and the greater than symbols. So let's start by solving our first inequality. We have the absolute value of n minus 8 is less than or equal to 2. The first thing you want to check, you want to look at each side of the inequality. And so if I look at the left-hand side, I see I have the absolute value. Everything is inside of my absolute value. So that means that's going to be a positive number. And then I have is less than or equal to another positive number. Since I know a positive number can be less than or equal to another positive number, example, if I had 1 is less than or equal to 2, that's true. So I know it's possible. That means I can start working on this problem. So the first thing we do, I don't know if you guys remember solving the absolute value equations. Hopefully you do, but I know sometimes it's easy to forget things. So I'm going to refresh your memories. Remember with absolute value, we do a case 1 and we do a case 2. So our case 1, we always take the left-hand side of the inequality and we just get rid of the absolute value. Now for case 2, what we do is we take what's inside the absolute value. So we have n minus 8. And when we solved equations, we would set it equal to the negative whatever number was on the other side of the equal sign. We're going to do that again. So we're going to have a negative 2. But when we do that, we flip our inequality sign the opposite direction. Kind of like when you divide by a negative or multiply by a negative, this is that same idea. So when you do case 2, you set it, you have the negative version of our number, and you flip your symbol. Then from there, all you're doing is solving inequalities. So I add 8 to both sides. I have n is less than or equal to 10, and I have for case 2, I add 8, I have n is greater than or equal to 6. So what I do is, now I look, I have n is less than or equal to 10, and I know that's going to go this direction, and I have n is greater than or equal to 6, so I know that would go this direction. So my answer is where they overlap. So that's actually going to be, the graph would look like the black graph. That would be our solution. And the way you would write your solution for that, the book is going to use set builder notation. They're going to show you that your variable's n. They're going to take your smaller number and rewrite your inequality so that way your two inequalities as one inequality. Or you can use the word and between the two of them. Okay? I will accept either this or I will accept the set builder notation. Okay? So now let's look at case 2. Just going to rewrite it over on the side here. We have the absolute value of 2c minus 5 is less than a negative 3. So the first step, let's see, we have on the left-hand side, everything's inside our absolute value, so this is going to be a positive number, is less than a negative number. Can a positive number ever be less than a negative number? No, so that answer is null set or no solution. Okay? Why don't you guys go ahead and try to solve this first one on your own? Hopefully you realize that this was a positive is less than a negative situation, so that means there is no solution. Go ahead and try this next one on your own. Hopefully for this second one, you determined that our answer is going to be letter C. We have P, or negative 10 is less than P is less than 2. If you have questions about that, be sure to ask. Alright, let's take a look at example 2. We have a positive is less than or equal to a positive. Okay, that can happen, so let's go ahead and solve. We do case 1. We have n minus 3 is less than or equal to 12. For case 2, I have n minus 3 is, I have to flip my inequality symbol, greater than or equal to negative 12. Now I just go ahead and solve it like a normal problem. So if I add 3 to both sides, if n is greater or less than or equal to 15, and if I add 3 to both sides on case 2, I have n is greater than or equal to negative 9. So then on my graph, I'm going to say that 15 is probably out here somewhere. So my first one, I have n is less than or equal to 15. So I have my dot at 15, and I know it would go that way. And then n is greater than or equal to a negative 9. So here's negative 9, and greater is going to go this way. So that means my solution is anywhere they overlap. So from negative 9 all the way up to 15. So the black graph would be my solution. I would write my answer as n, and then I would have negative 9 is less than or equal to n is less than or equal to 15, and close the set builder notation. All right, now let's look at example 2b. We have a positive is less than a negative. Again, that can never happen, so that is the null set or no solution. Excuse me. All right, example 3. We now have the absolute value is greater than. The other examples we were doing were all less than. Now let's talk about some greater than. So I have a positive is greater than a positive. Well, that can happen. So we set up our 2 cases. We have case 1, 2k plus 1 is greater than 7. We set up our second case. We have case 2. We have 2k plus 1 is less than, because I have to flip that inequality in order to make this a negative 7. If I keep going, on case 1, I subtract 1, I have 2k is greater than 6. Keep going, divide both sides by 2. I have k is greater than 3. And then if I go over on the other side, I have minus 1, minus 1. If 2k is less than negative 8. Divide both sides by 2. I have k is less than negative 4. For this instance, I have k is greater than 3, so I have an open circle pointing to the right. For case 2, I have an open circle at negative 4, and it's pointing to the left. In order to write this solution, I'm going to expect you to write k is greater than 3 or k is less than negative 4. If you don't feel comfortable writing that, you can try writing set builder notation. It ends up being a little bit different for the or instead of the and. Remember the last couple examples were and problems? This problem's an or compound inequality. So we have negative 4, and watching my symbol, it's opening up towards the negative 4. And then for k, it's opening up to my k, and it has 3 on the other side. Okay? Don't try to graph from this, because that can be confusing. Graph them individually like that. That'll make your life a lot easier. Now let's look at letter 3b, or number 3b. We have a positive is greater than or equal to a negative. Is that true? Yes. Is that always true? Yes. Whenever you have a positive number is greater than a negative number, it doesn't matter what number you plug in for your variable, because no matter what, that side's going to be positive, And no matter what, that is going to be bigger than a negative number. So that means your answer is all real solutions. And your graph, your number line graph, if this was your number line, so 0, 1, -1, your graph solution for all real solutions is to highlight the entire graph, okay? To highlight the whole thing for all real solutions. Remember, all real solutions when you have a positive is greater than or equal to a negative number. But if you have a positive is less than or equal to a negative number, that's your no solution. So go ahead and try solving this one on your own. Hopefully you determined that the answer was letter D. If you have any questions about that, be sure to ask for some help. Alright, example 4, we have a positive number is greater than a positive number. That's possible, so let's keep solving. We have case 1 is 3y minus 3 is greater than 9. Case 2, we have 3y minus 3. Flip my sign so I can change that to a -9. So 3y minus 3 is less than -9. If I go, I add 3, I have 3y is greater than 12. If I divide both sides by 3, I have y is greater than 4. And if I keep solving over here, plus 3, I have 3y is less than -6. Divide both sides by 3. I have y is less than -2. So if I go, y is greater than 4, that's going to be my green graph. My blue graph is going to be y is less than -2. So you can see it goes out like that. When it goes out like that, it's called an or statement. So you can say y is greater than 4 or y is greater than is less than, y is less than -2. And then if we look at letter B, we have a positive number is greater than or equal to a negative number. That's always true. So you say all real numbers, and then your graph would be highlighting the entire graph number line. Go ahead and try this one on your own, see how you do. Hopefully for this one you determined x is always going to be a real number because we have a positive is greater than or equal to a negative number. If you have any questions at all, be sure to either ask myself or a friend. Have a great day.